Hi everyone, welcome back to another video. My name is Devang and in this video we will be discussing about circular queue. So in the previous videos we saw like how we can implement queue with the help of the arrays. Alright, I told that this was the naive approach. Why this was a naive approach? Because in this kind of a things we are just using the representation via some like classical data structure. We are not implementing some optimizations and all that, and we are not considering the time complexities as well. Let us try to analyze the time complexities of the implementation of the queue that we did the standard one yesterday in the video. Okay, so the insertion one, like if you want to insert any element in the queue, it would take big O of one time. Because we are just inserting an element in the array. Perfect. The Enqueue function, let's talk about this. How much time complexity it will take? At max there will be a loop. At max the loop will run for, in the worst case the loop will run for big O of n times. So this is not a good time complexity. Why? Because let's say that you have a number of test cases and the Enqueue function is taking big O of n time. And as I already told you that the online judges just work for 10 to power 7 seconds, 10 to power 7 computations in 1 second. So it would give a time limit error. So now let's try to just optimize our code, and implement the circular queue one. Okay, so yes, let me just rub these things. Okay, let me just rub these things. Okay, so let us understand the term circular queue. What is circular queue? What we did, we take this kind of a queue in the standard implementation. What we did, we say that hey, I can insert 100 over here, I can insert 200 over here, and if I want to delete one element, I have to move all the elements over here. Like I have to move 200 over here. This one of the insertion pattern. Now I'm saying do a thing. The circular queue says that do not do this thing. Do this thing. Let's say that you are having the elements 100, 200, 300. This one is your front element. And this one is your rear element, right? The circular queue mechanism states that do not consider the deletions in this manner. What should you do? You can just move the front pointer upon here and rear pointer upon here. Okay. I think that this must be confusing to you, but try to think like this way. So let me just mark some of the divisions upon here. Okay, sorry about the drawing part. Yeah. So try to think that this is your 10, this is your element 10, this is your element 20, this is your element 30, this is your element 40, this is your element 50, 60, 70, 80, 90, 100, 110 and 120. So at this moment your queue is full. What I did, I just rotated this queue to this form. I just twisted it. I took this queue and just twisted it. Try to think of this way. Now my queue is full. This is my front element and this is my rear element. But I just queried to delete an element. So should I move all the elements back here? No, this is not that part. We want to optimize our approach. So what will I do? I will just move my front to a different position. I will move my rear. Now understand some things over here. My front is not always 0. This is the main thing which you want to learn in that of the circular queue. Front is not always 0. Now this is front now. This is my front now, and after deletion, and this is my rear now. This is my rear now. Here I can insert an element. I will override this position. I will override this position and I will insert an element over here. Yes, and I will insert an element over here. So what I did, I said, okay, let me just move to another page. What I did, I said, let's say that we are having 10, 20. Let me just make it more darker. Okay, so let's say that we are having 10, 20, 30, 40. This as our initial queue. This is our initial queue. Okay, so this is our initial queue. This is our front element and this is our rear element. So I said dequeue. I called dequeue function. I called dequeue function. So what I did, I said do nothing. Just move front element over here. 20, 30, 40. Now this is your front and this is your rear. Here 10 is there, here 10 is there. We haven't erased it yet, but try to visualize like this. Try to visualize that, okay, 10 is over now. Try to visualize this. I am using the term visualize. Try to visualize this, that 10 is not there. Just for a moment, we haven't deleted it yet. We just moved this way. Then I again called dequeue function. So what I will do, I will simply say, okay, this is my position. So keep 30 and 40 and this is my front and this is my rear. Here I was having 10 and 20. I haven't erased this yet, but I am assuming that they are erased. I am visualizing that they are erased. So this is my 30th element and this is 40th element. Now I said Enqueue 100. Now I said Enqueue 100. So I have two empty places with me, two hypothetical empty places with me. Why empty places? Because I am see the computer, the CPU does not know that I can that this data is important or not, the computer can override. He's just a machine. Computer is just a machine. Let's say that this is a bucket and here you have kept 20 and you say to CPU, hey CPU, go again to that position and keep 20 over here. So computer will say okay master, I will just keep 20 over here. For computer is very easy task. It just follows what you instruct. So as simple as that, we will say, hey computer, now move rear to this position. Let me just draw it over here. Okay, let me just draw it over here. So what I will say that this is my front element and now this is my rear element and here I have inserted 100. So this is so beautiful, right? Like this is a circular thing. Now if you just see, see, this is a circular representation. That is why it is known as circular queue. What we do, we basically move. Here we have movable front pointer. The front pointer is not fixed upon here. This is the main crux of the circular queue. The front pointer is movable upon here. We move that and we use some mathematical calculation. I will talk about this in the later part of the videos. We do some mathematical calculations to calculate new positions to insert element. Okay, so as here I have calculated that here I have no platform available, so move in a circular manner and insert on our visualized emptied space. This is the main crux. Okay, so now can you just think of the time complexity of this? The insert part is again big of 1 the delete part is again big of 1. Why? Because you are not doing anything, you are just incrementing your front pointer, and incrementing of front pointer will take absolutely constant time, okay? So it is big O of 1, and also you are not wasting any space, This is the main thing of the circular queue. Sorry, this is the main thing of the circular queue, and it will help you in a lot of situations. Okay, let us try to again think of one example, and then we will move to the coding part, like how can we implement. Okay, so let us try to think. We are having this 100, 200, 300. Now my queue is full. And this is my front element, and this is my rear element. Now I want to enqueue. Sorry, not enqueue. Enqueue will, if I do enqueue over here, it would result in overflow, because my capacity is equivalent to size. So it will just result in overflow. I want to dequeue an element. So what I will do, I will say okay. Just a minute. I will say okay, this is virtually ended for me, and now my front pointer has moved upon here. And then I say that, hey computer, enqueue 20. So I will do some mathematical calculations. I will talk about the mathematical calculations now, and after doing some mathematical calculations, it gives me the position where to insert. It says this position is virtually empty for you, go and insert here. So here my 20 is inserted, and this is rear for me now. So now the condition of the queue has become 20, 200, 300, where 20 is my front element and this is my rear element. Again, if you see properly, this is a circular manner. So now let's talk about what is that mathematical calculation. We have discussed various things. Let us talk about the mathematical calculation upon here. Okay, so the mathematical calculation, it is not a big part. It is a very super easy part. Mathematical calculation, it is a super easy part. Yeah, let us try to think of what I was saying. Okay, so try to think that this is your queue. Here you are having 100, here you are having 200, and here you are having 300. And this is your front element, and this is your rear element. After some time you did deletion, so your queue became 200 and 300, and this is your front element as of now, and this is your rear element as of now. Now you have a query to insert an element 20. But the question is where to insert. In the earlier videos, we saw in the standard implementation that we took the capacity pointer and all that and used that to implement in the queue. But now how can we just insert, because my front pointer is movable on here. The position is given by rear. My rear would become or let us just think like this. My position is equals to front plus size minus 1 modulo capacity. This is the thing which is the main crux. The main crux was first of all movable pointer, and now we have mathematical calculation. So this is the crux. Now 0, 1, 2, the capacity is 2 yet, and the size is 3. Okay, this is the current position of our queue. So the position would be front, which is 1. Here the index is front 1, the size is 3, and minus 1, the modulo means remainder. Modulo means remainder. Capacity is sorry, the capacity is 3 and size is 2. The capacity is 3 and the size is 2, so 2 modulo 3. So it would become 2 modulo 3. 2 modulo 3 is 2 over here. But is it right? Is it right? No. So there is one more step ahead, which is position is equals to position plus 1 modulo capacity. Modulo capacity. It is just a circular thing, right? So position is 2 plus 1 modulo capacity. So 3 modulo 3, it comes 0. Yes, it is the right answer. 0 is the right place to insert my element. So I will say position is equal to 0. I will move 20 over here and rear would become this. All the things are sorted now. All the things are sorted now. Let us quickly see once again what I did. Let's say that this is my 40, this is my 50. I want to insert 10. This is my front. Okay, let us take another element 60, and this is my front and this is my rear element, and I want to insert 10, and the capacity is 1 2 3 4 and the size is 3. So how can I know what is the position? I would recommend you to pause this video over here and try to think of the position. So the position would be front plus size minus 1 modulo capacity. So the front is actually, if you aren't in a way to understand this formula, you can learn this way, FSC. Actually, you do not have to learn, never learn these kind of things, but yes, sometimes people just have some kind of a difficulty to understand this formula. You can just learn this one. Okay, so front is let me just index one over here. So front is 1 yet, the size is 3 minus 1 modulo capacity is 4. It would become 3 modulo capacity. It is 3. Yes, but is it the right position? No. Again, one more step. Position is equals to position plus 1 modulo capacity. Position plus 1 modulo capacity. So position would become 3 plus 1, which is 4 modulo capacity. Capacity is 4, which is 4 modulo 4, which is 0, and it is the correct position. So just go to the correct position and insert. All things are working now. This is the main thing. This is the most easiest thing. I always say circular queue is easier than that of standard queue. Circular queue is easier than that of the standard queue. And here circular queue has all the operations as big O of 1, which is the major advantage for us. So let us now implement this. Okay, so this is the implementation. Let us try to understand this. This is a super easy one. The code is just bigger, that's why I just pasted the screenshots one. So but this is a super easy one. Okay, what I did, I simply take an array pointer, a size pointer, a front, and a capacity. Now this size is my current size, this size is my current size, this one is my array, this one is my array, and this one is my the maximum size which the queue can hold. The maximum size which the queue can hold. Now this is my constructor. These things are private. These things are private. This is the public part. Why private? Because I do not want user to get access of these elements, these members. Now sorry, this this is my constructor. Inside the constructor, I would be receiving a size, which would be the maximum size of my queue. I say that maximum size is equals to C, array is equals to new int dynamic allocation, front is equals to 0, and size is equals to 0. That simple as that. This, if you compare this, these are the standard queue implementation part. These are the standard queue implementation part. Now I have a function bool is full. Now what it will check? It will check that if my the queue is full or not. It will check my queue is full or not. What I did, if I said if capacity is equal to side, return true, which would mean that yes, my queue is full, and else return false, it would mean that my queue is not full. Then I'm having another function is empty. If my size is equal to 0 would return true, that my bool is empty now. Why I'm using this? To avoid overflow. To avoid overflow. Okay. So let me just highlight this part. Okay, yeah, just a minute. Let me just highlight this part. Yes, I am using this to avoid overflow, because if I enqueue any element, and my queue is having all the elements, so I should not enqueue any element. So that's why I have used is full and is empty. Is full is for enqueue and is empty is for dequeue. Is empty is for dequeue. Okay. So size is equal to 0, return true and return false. This is the easiest part. This is the easy part. Now here I have a get front function, get front method. What it will do, it will return the front. It will return the index front. It will return the index front. Firstly, it will just check that my queue is empty or not. If empty, it will return -1, else it will return front. And then I am having get rear. Now this let me just, yeah, this is the position one. This is the position. In the last segment of the video, we saw that position is equals to front plus size minus 1 modulo capacity. This is that part. This is that part. Let me just highlight this. Okay. No, this is not the right color to highlight. This is not the right color. Leave. Okay. So this is that part. Basically, this is that part. That if my empty, this is basically this will return the position where I have to return, where I have to insert. So if it is empty, return -1, else return front plus size -1 modulo capacity. Modulo capacity. Okay. Here I am having a void enqueue function. Void enqueue function. Now what will this function do? This function will basically insert an element into the, that of the queue. It will insert the element in that of the queue, and firstly it will check the position. It will say, hey, give me position. Do not confuse rear. Rear just means the position. Rear just means position. And as I said, there was another step in the mathematical calculation. This is that step. Rear is equal to rear plus 1 modulo capacity. Then it will say, hey, insert the element and increase the size. As simple as that. Guys, can you understand that? This is very simple. Now let's see the last function. Actually the space was a bit less, so I just left the dequeue part. Let us now cover the dequeue part. Okay, so this is our last part, which is the dequeue function. Now what dequeue function will do, it will delete, and as I said, this is just a visualization. This is just a visualization. Nothing is getting deleted. No memory is getting deleted. We are overwriting the memory. Okay. So try to understand this part, guys. Try to understand this part. That's why we are able to achieve big O of 1 complexity. What we do, I will again highlight this part. This part is important. I will just, sharpen this part. This is very important. We are not deleting anything. We are just overwriting it. So what we did, we basically checked like it is empty or not, to avoid any kind of overflow. Then what we did, we say the front is front plus 1 modulo capacity. Yes, simple as that. We just moved the front pointer. And then I said decrease the size. Yes, this is pretty much that. This video covered your whole circular topics in about 25 minutes, guys. This is the beauty of circular queue. I always say circular queue is the best part where you can learn. So I hope that you understood this video. If you have any doubt, there are two things which we can do. First of all, you can comment out in the video box, so in the comment box, or else you can go to the launchpad section of Newton School. In launchpad section of Newton School, we are having various advanced teachers which are there to help you for free. They can counsel you upon which you want to know, and the launchpad section is having a lot of courses for you so that you can enroll and get all the things and all the skills that are required for you to placed in a very awesome company. Okay, so I hope that you understood the concept, and this was that on my part. If you are happy, make sure to like the video, and we will meet in the next part. Till then, bye bye.